Okay, so continuing on to ways we can use trigonometry in non-right angle triangles, we get the cosine rule. Now, the cosine rule looks a little bit more complex than the sine rule, but you only really need to know how to apply it. We don't need to worry too much about remembering it because it's usually provided in formula sheets. Even in year 11 and 12, it's provided in formula sheets. And you don't really need to worry too much about how it's come up with. Now, I am going to link in this lesson for today, I'm going to link to a video where for my standard maths class, I explained where the cosine rule came from. No one's required to watch that. You can if you want to. It's not altogether too difficult. Proofs of these things can be a bit scary, but if you think about it, you guys would all be pretty comfortable with the area of a circle rule, for instance. Area is pi r squared. But in order to prove that rule, you need year 12 mathematics, or maybe year 11. But either way, you need advanced maths. You need to be doing at least advanced maths in year 11 and 12 before you get into the maths that allows you to prove that rule. This particular rule really is proved using quadratic equations, Pythagoras theorem, and simple right angle triangle trigonometry. So although it might appear complex, some of the simpler things we've dealt with in maths are way more complex to prove and require knowledge way outside of what you currently have. So it's worth having a look at being able to do that and pull that apart. So this is this particular one. What I really want you guys to focus on with this is diagnosis. I want you guys to be able to look at a triangle and decide which is the best method for working out the answer to the problem. And if you remember from the sine rule, we were looking for an angle and opposite pair. So an angle and its opposite, and then another angle and its opposite is what we were looking for. In this particular case, we're looking for an angle, we're looking two sides and an included angle. Two sides and an included angle. Okay, if we have that situation where we've been given two sides and an included angle, we can find the opposite side. We can discover this one here. We'll also use this same formula to be able to find one angle when we know all three sides. Okay, but that's the main thing you're looking for here is a relationship between two sides and the included angle. Not two sides in any angle, two sides in the included angle. Okay, so as we look down here at this first one, in this particular case, here is our, that's going to be there, our two sides. And this here is going to be our included angle. All right, so as you can see, we'd be looking in this particular version here, to go with this formula, we want that side, and we want this angle here. Okay, so cos of C is at that angle. All right, so let's have a look at our first example here. Here we've got two sides, that side there's given, that side there's given, and the included angle is given. So we've got two sides and an included angle, and that will allow us to work out the length of the side opposite. So let's start substituting this into our formula. So our formula, and once again, get in the habit of writing down the formula first. So write down the formula, then substitute into the formula, and then evaluate. That's not just so you don't make a mistake, that's also so you communicate to anybody who's reading your work that you understand what it is you're doing. Okay, so c squared is going to be what we find out at the end. And actually, in this case, I'm going to call that x squared because that's the length that we're looking for. And then it doesn't matter which of the two sides I call A and B. It won't make a difference. I can just choose whichever I want to be either A or B. So I'm going to go 6.2 squared plus 8.1 squared minus 2 times 6.1 times 6.2, sorry, my mistake. 6.2 times 8.1 times by cos of 50.5 degrees. And then all I have to do is plug all that into my calculator. I'll move that over here so we can read it all. So 6.2 squared plus 8.1 squared minus 2 times by 6.1 times by, did it again. 6.2 times by 8.1 times by cos of 50 0.5 degrees. And I plug that into my calculator and I get a rather big size of a side for where that triangle is. So I'm just going to write 40.16 dot 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 dot, but remember that equals x squared. All right, we started with a square on this side. So in order to find x, we're going to have to take the square root of 40.16, whatever that was in the calculator. And we'll do that by just going the square root of the last answer and press equals. And that's going to leave us with, to one decimal place, 6.3. And it's a distance, so we better look at units. Well, it doesn't say any units on there, so I'll just write units. Okay? So for the next example, once again, we better just check it is a cos rule question. I've got a side, I've got another side, and I've got the angle that sits between them. And what it wants me to find out is PQ. Well, there's PQ there. That looks like a perfect time to use the cosine rule. We can't use the sine rule because we don't have the right pairings of angles and sides. So I can't, the 6.6, I don't know the angle that's opposite. 5.3, I don't know the angle opposite. And then the 126 degree angle, I don't know the side that's opposite. So I don't have any pairs at all to use the sine rule. So this is where the cosine rule comes in. I've got two sides and an included angle. So let's start using that formula. Remember, the formula is in the form of c squared equals a squared plus b squared minus 2ab cos c. Remembering that is not your main focus. Your main focus is diagnosing when to use it. All right, that's the way more important skill. Memory, being able to remember something that's always going to be provided for you when you need it is kind of a waste of your time. So once again, in this particular case, we're going to say, well, that's PQ squared. And it doesn't matter which one I call my A and my B as long as I know which one my C is. So 5.3 squared plus 6.6 squared minus 2 times by 5.3 times by 6.6 times by cos of 126 degrees. So I'll plug all that into my calculator. That's the only problem, I suppose, with the cos rule is there's a lot of plugging into the calculator. So 5.3, 6.6 squared minus 2 by 5.3 by 6.6 by cos 126 degrees. And we close that off and we get 112.77. And there's some more digits after that. But of course, that gives me the length of PQ squared, but what I actually want is the length of PQ. So I'm going to have to take the square root of that number I have in my calculator. Once again, just getting used to that method in the calculator of using the answer key. Square root of the answer, let's get something more exact. So 10 to one decimal place, that's going to be 10.6. And what are my units? It doesn't say, so I'll just say units. It doesn't say it's millimeters or centimeters. All right, I think you'll find as you have a go at these exercises, you'll find this probably a little bit on the easier side because it really is just a case of when you're doing the questions in the book, you already know you've got to use the cosine rule. What I want to see when I see your work is I want to see the formula. I want to see a line of substitution before there's any evaluation, okay? I want you to make it clear to yourself when you ever come back and look at your notes that this is how it gets worked out, okay? Cutting corners on this one would be a waste of your time and you won't find much of this too hard. All right, so while it looks a bit confusing, it really is just a case of substituting into a formula, just like you would substitute into pi r squared to find the area of a circle. All right, have fun with that one, and I'll talk to you about the cosine rule for angles next.